Hi everyone, welcome to another video, and today we're going to be focusing on the topic of coasts, which is topic 2.3 in the syllabus. So first we're going to be looking at the factors affecting the size of a wave. So one factor is the speed of the wind. And this is because if the wave can get enough momentum from the speed, then the size of the wave will be bigger. So the next is the fetch of the wind. And if you don't know what fetch is the distance the wave travels. Okay. And then the final factor is the amount of time that the wind blows for. So if the wind is blowing for a longer amount of time, that will increase the size of a wave. Okay, so now we're going to be looking at two important key terms you need to know, which are swash and backwash. So swash is the movement of waves carrying material up the beach. And backwash is quite literally the opposite. So the movement of waves carrying material down the beach. Okay, so these are two definitions that you need to know, because you will need to know them in order to answer questions in the exam, as they will just refer to the terms swash and backwash when they're phrasing the exam questions. Okay, so now we're going to be looking at the types of waves that exist. So the first type you need to know is constructive, and the second is destructive. So we're first going to be looking at constructive. So constructive waves have a low frequency and this is due to the long wavelength. As you can see between these 2 points on the wave, the length is long. It also has a shallow wave gradient. I'll write down this side. Shallow wave gradient. And because these waves have low frequencies and have a shallow wave gradient, this means that they have low energy. And because they have low energy, they have a strong swash up the beach. And therefore they will have a weak backwash down the beach. Okay, so now we're going to be looking at destructive waves. So destructive waves have a steep gradient, as you can see. So steep gradient. And as you can see, there's a short wavelength between each wave. Short wavelength. And because the wavelength is short, this means that it will have a high frequency. And because of all these factors combined, the wave will therefore have high energy. And therefore, when it comes into contact with the beach, it causes a weak swash. However, there is a strong backwash, so strong backwash. And this then forms the basis of longshore drift, which we will look at in a bit. Okay, so next we're going to be looking at coastal erosion and the processes of the coastal erosion. This is very similar to hydraulic act to sorry no. Next we're going to be looking at coastal erosion and the 4 different processes of it. This is very similar to the erosion in rivers, so there are just a few minor differences that you may need to know. So the first one is hydraulic action, which is pretty much the same as rivers. So the force of water getting into the cracks of the seawall. So instead of the riverbank, it will be the seawall in this case. And attrition is the same as well. So sea material bounce off each other. Next is abrasion. So abrasion is when waves pick up material and hurl it at the sea wall. So as you may notice, this definition is not the same as for rivers, where in rivers the material scrapes the riverbed, but in this case the waves pick up the material and hurl it at the seawall, so this causes further erosion of the coast. And the last one is corrosion, so this can also be known as solution. And this is seawater that is acidic and can dissolve sediment. Okay, so that's all you need to know for coastal erosion. And now we're going to be looking at coastal transportation. So the first one we're going to be looking at is traction. So this is heavy material that roll along the river bed. The next is saltation. So this is when smaller material bounce along the sea floor. And the next one you need to know is suspension. So suspension is when sediment is held in the water. It's not dissolved, but it's just suspended within the water, hence why it's called suspension. And solution is where sediment is dissolved in the water. Okay, so that is all you need to know for coastal transportation. And now we're going to have a look at coastal deposition. So coastal deposition is where longshore drift takes place and how the deposition of material on the beach works. So what happens first is that waves approach at an angle, as you can see here. So waves approach at an angle. And this is because it travels in the direction of the prevailing wind. So the prevailing wind is the wind that is blowing towards the coast, so the waves will travel in this direction. However, after the swash, so the waves swash up the beach. So after the swash, the waves will backwash at right angles or 90 degrees, so it'll backwash perpendicular to the coastline. And this process, as you can see, just continues until you get here. So at this point, we're going to change color because this is a formation of a coastal landform that you need to know. So this continues, and then eventually at this stage, the wind direction may change. So the coastline elongates along here because wind direction changes. So the coastline deposits out into the sea. And this is basically what a spit is. So the features of a spit you need to know is that it has a hooked end at the end of it. And this sheltered zone here is a salt marsh, which develops behind the spit. Okay, so now we're going to be looking at more coastal landforms, and we're first going to look at cliffs and wave-cut platforms. So this image is shown when the sea is at low tide, so hence why you can see the wave-cut platform. But when the sea is at high tide, so I'll just draw an image here. When the sea is like around this height maybe, it'll come into contact with the cliff side here. So the waves will collide with the cliff at what is known as the nick point. So the nick point is the point at which the waves comes into contact with the cliff. So nick point. And when it does this, it creates a notch. So creates a notch. And the notch is basically a hollow in the cliff wall. So because it creates a hollow, this process will continue. And this process is done by hydraulic action, abrasion, and attrition. And this will continue until eventually the cliff will become unstable because there's a large part of the cliff that's unstabilized, so it will collapse, and this causes the cliff to retreat backwards this way. And then when the water goes to low tide, as I said at the beginning, this will form a wave-cut platform. So that's basically how it works. Okay, so next we're going to be looking at this cave, arch, stack, and stump formation. So at point 1, a crack is formed. In the headland, and this is done via hydraulic action. So you can see the crack here in the image that forms here as a result of hydraulic action. And then because this process continues, it grows into a cave, as you can see at point 2, to a cave. and then erosional processes like hydraulic action and abrasion continue. And this causes the cave to break through the headland at point 3. So cave breaks through the headland. So this is what forms an arch. So this part here is an arch. So forms an arch. And next, because this piece of the headland here is unsupported, it will eventually collapse into the sea, and therefore it will form a stump, which you can see at point 4. So top of the arch collapses, forms a stump, and then at point 5, there will be continued erosion on the stump, which causes it to become shorter, and therefore it will form point 5, which is a stump. So continued erosion forms a stump. Okay, so that's all you need to know for cave arch, stack, and stump. And next we're going to be looking at the formation of bays, headlands, and beaches. So what you need to know for this is that it occurs on coastlines with a discordant pattern. And what they mean by discordant is that it's alternating in hard and soft rocks. So in this case, the beige will be the hard rock, and the brown part will be the soft rock. So the soft rock. So basically, due to the resistance difference between the hard rock and the soft rock will erode first. So soft rock erodes because it is less resistant. Okay, and therefore it will erode inland, and basically when it does this, waves will come in and deposit material in the bay. So constructive waves deposit material in the bay. So when it does this, this is how beaches form, because of the deposition of sediment onto the coastline in the bay. Okay, so now finally we're going to be going on to coastal sand dunes. So basically how this works is that onshore wind will blow in this direction. So onshore wind blows sand up the beach. And on the beach there may be different obstacles. There may be a piece of driftwood, there may be rocks, there may be pebbles. So when there's an obstacle, say for example, I'll just draw one. So say for example, this is a rock right here. So the wind will be coming this way, carrying the sand. But then when it hits the rock, the sand will be deposited next to it. So sand gets trapped by obstacles. And this process continues, and the sand will continue to build up until it forms something like this, which is behind my diagrams. So these are coastal sand dunes here. And they are maintained due to the colonization of vegetation. So due to vegetation colonization, and this holds the roots together. Okay, so next we're going to be looking at the conditions required for the development of coral reefs. So the first one is warm water. The next one is shallow water because it needs sunlight for photosynthesis. And next it needs a plentiful supply of oxygen in the water, and also a plentiful supply of plankton, which helps build the coral reefs. And also the water needs to have gentle waves, so gentle water, so that it can grow. Okay, so now we're going to be looking at the conditions required for the development of mangrove swamps. So the first characteristic is saline water. So water that is high in salt concentration. The next is gentle waves, just like for coral reefs. There must also be a small temperature change in the climate. And therefore there will be there also needs to be warm water, and also there needs to be a large tidal range, so the range between the high tide and the low tide of the sea. Okay, so now we're going to be looking at the opportunities that coasts provide. So the first one is transport. And this is because transport, so how harbors can be built and ports as well. So it allows for the trade and transport, trade of goods, and also for tourists to be transported to the coastal area. The next opportunity provides is agriculture. So this is because areas surrounding the coast have fertile soil and they will probably be well drained. So this allows for crops to be grown, and then farmers that owns these areas of fertile soil can grow crops and therefore produce income for themselves. Next is fishing. This is because in coastal areas there are a high abundance of marine ecosystems, and therefore there'll be a high diversity of fish, and this can also increase food production. The next is tidal power. And this is because there may be a large difference in the tidal range of the specific coastline. So it allows for electricity to be generated for the nearby areas, and also in a sustainable way. And finally, it allows for tourism. So there may be water sports such as jet skiing, snorkeling, etc. And coastlines also provide beaches for leisure and relaxation. Okay, so although coasts provide opportunities, there are also many hazards that coasts can present. So one is tropical storms, and this is because there may be destruction. So we destruction to the infrastructure and houses, and this can therefore lower the economic productivity in the area if there are factories or any oil or gas stations that are destroyed near the coast. So the next is coastal erosion. So this can again cause the destruction of housing and infrastructure. So coasts can also erode fertile land away. So farmers may be under unemployment because they won't be able to grow crops and produce income for themselves. So this could also lower the agricultural productivity in areas that are near to coasts, and therefore rising sea levels. So this can cause problems because it can cause salt water to intrude into fresh water sources, and this can therefore decrease the water availability for residents in the coastal area, and therefore it could have many impacts such as decrease industrial productivity and also can increase dehydration. So although there are many hazards, there are many coastal management schemes that we can use to mitigate the effects of coastal erosion and all the hazards above. So the first one is beach replenishment. So what this is taking sand from the sea bed and placing it on the beach, and this definitely helps to reduce erosion by quite a lot. The next is manage retreat. So this allows the sea to flood inland in a controlled manner. So although the area in which the coastal erosion will take place will be abandoned, it reduces the casualties of people living in those areas as they will be asked to leave and evacuate. So there will be less casualties. And this leads to the next one, which is the placement of vegetation. So this stabilizes sand dunes, as we discussed during the formation of the coastal sand dunes, and reduces wind erosion. Okay. So next we're going to be looking at the hard engineering schemes that could be used. So the first one is sea walls, and these are curved walls that can deflect wave power. The next is rock armor. So this is when rocks and boulders are piled on the beach so that the wave energy can be absorbed. And finally, gabions, they are cages with rocks, which also helps to absorb wave energy. And therefore, all these methods therefore decrease coastal erosion. Okay, so now we're going to be looking at the case studies that you need to know for this topic. The first one you need to know is an example of a coastline. So for the coastline, you need to know 3 management strategies to combat coastal erosion. 3 hazards and effects, so that can be your tropical storm, your erosion, etc. And therefore, you should also include 3 opportunities that the coastline provides. So the other case study you need to know is an example of a tropical storm that happened. And all you need to know for that tropical storm are 3 effects of that tropical storm on both the environment and people. Anyways, that's all for today's video. I hope you guys found this useful, and I'll see you in the next one. Bye.